Let's do a rate in, rate out problem, but we got a table of information, makes things a little bit harder to calculate compared to when we just had our calculator. Make sure we understand what's going on. We have a rate in, W in liters per hour. That is a derivative. So W is a prime. The units are liters per hour. That means if you accumulate W, you'll get liters. If you take the derivative of W, you'll get liters per hour squared. We got water removed by R. Here's select R's. R is also a derivative. R is decreasing and differentiable. We have an initial amount, 50,000 liters. Remember, if you accumulate W and R, we just get a change in a total. We won't get a total unless we have the 50,000. R prime of 2. R prime would be a acceleration, liters per hour squared. I'm going to do 950 minus 1190 over 3 minus 1. Again, negative 120 liters per hour per hour. R is decreasing by approximately 120 liters per hour per hour. There you go, Boone. There you go, Boone. If we accumulate R, we'll get the total removed in liters. Total liters removed. We're going to use a left Riemann sum. 0 to 1, base length of 1. Use 1340. 1 to 3, base length of 2. Use 1190. 3 to 6, base length of 3. Use 950. 6 to 8, base length of 2. Use 740. $80.50 liters. This is the approximation over or under the actual. R is a decreasing function. I'm using a left Riemann sum. Therefore, it's going to be over. How do I know that? I know that a decreasing function, if you're using a left Riemann sum, we'll use the highest y coordinate over said base. The rectangle will be above the curve. We'll have an overestimate. What is the rate that the water level is changing at t equals 3? This is when we look at the velocity of our overall situation, where the velocity is w minus r. I want how the position is changing. I want the derivative of the position. I want the velocity value. The velocity at 3 is w of 3 minus r of 3.
It's so much, bro. It's better than like.
And let's graph down the front. Oh, it's a pie, bud. Yep. So I got W of 3. And what's R of 3? Well, R of 3 is this value right here. R of 3 is 950. This is in liters per hour. This is in liters per hour. Therefore, this is in liters per hour. So this is the water level is increasing by this many liters per hour. Let me pause. Okay, we got 50,000 liters in the tank. We will accumulate the rate in. We will subtract the accumulation of our rate out. In the past, we did this and we accumulated our velocity. Problem is, since R is a table form, we can't just plug it in and accumulate it. We're going to have to do this separately. So we need to accumulate W from 0 to 8. That's the amount added. And then I need a trapezoidal Riemann sum for the total removed. All right. One half x sum of the y's. One half x distance sum of the y's. Half x distance sum of the y's. One half x distance sum of the y's. Cool. So 50,000 plus this number minus this number. 50,456.
Door's locked. Make sure you're not in there by yourself.
I was saying that.
If R was decreasing at an increasing rate, that means decreasing concave up. Trapezoidal sum would be over.
It may. Are you okay? I don't teach in the afternoon, so I'm gonna go. I don't even think great.
Yeah, no,
But are
we'll
you
be-
okay
like
with
whoever, like we'll clean up. It's all
I
good.
mean, I don't think it's a big deal. I don't think it's that.
Since we're over approximating R, and R accumulated will be the total removed. We are over approximating the total amount that we are removing, which means our level is going to be under the actual. Aha. So our time level in the water is going to be a constant. Well, let's look at W from 0 to 8. I can kind of see it. Cool. W starts at 2,000, and then at 8 gets to 78. R starts from 1340 and gets to 700. So you kind of think about it, and this is kind of what you're going to describe, is that
Damn, what are you, a nigga? What? I just saw you standing right there. I told you. Wait like that.
W decreases from 2,000 to 78. R decreases from 1340 to 700. there will be a time when W minus R equals 0. There'll be time when W equals R. As we're decreasing from a higher to a lower compared to the other one. So that's what I'm going to go with. I mean, it's like just talking about how they're continuous, probably too. Later. You could look at like W of 0 minus R of 0 is positive. W of 8 minus R of 8 is negative. Therefore, there is a time when W of 8, W of t minus R of t equals 0. I like that. This is by the intermediate value theorem. Cool. This question was exactly from the 2024 free response. What's important with this question is understanding that the temperature of the coffee in the cup is in degrees. We are in the position land. C of t, which is in degrees, is a position. Velocity would be c prime, which would be degrees per minute. Acceleration, c double prime, would be degrees per minute squared. So, c prime of 5 is approximately 69 minus 85 over 7 minus 3, which is negative 16 over 4. Which is negative 4. What's the units? Degrees per minute. Okay. That means the temperature in the cup is decreasing. Make sure you understand that if C prime is negative, C is decreasing. Look, C values are decreasing. So that must mean the derivative is negative. Approximate the integral from 0 to 12 of C.
Thank you.
We've left Riemann sum again, so we got 0 to 3. We got 3 to 7. We got 7 to 12. I'm going to leave that for your response. You don't have to simplify. Okay. And this is in degrees minutes. Degrees per minute, it's degrees times minutes. I'm taking my degrees and multiplying by minutes. They didn't ask you for that value or those units, but you should understand that when you divide by 12 minutes, that you get degrees. So this guy right here refers to the average degrees or the average temperature of the coffee in degrees.
Yeah, do some quiet, please.
We have our derivative of C from 12 to 20. Well, our derivative of C, if accumulated, will tell me how much my temperature changed. It's a value. C prime being positive means C is increasing. You accumulate C prime, you know how much it increases. What's very important about this is that you're going to accumulate C prime and that will just give you the change in temperature. Now, here's something that's interesting. I'm glad it's showing up now. You are not allowed to graph a derivative. So if I try to type C prime, it won't. Doesn't like it. What you need to do is say C prime's a V. Now you'll be able to see it. Now you'll be able to accumulate it. So just maybe for the purposes of using Desmos, graph it as V. Now, when you accumulate V, you get this negative 14.67. That is not the temperature. Your coffee is definitely not negative 14 degrees Celsius. That's very frozen. 0 is freezing in Celsius, right? So what do we need? Well, we got to know what C at 12 is. We got to know that this is the change. Turns out my derivative is negative, which means my temperature is decreasing. And that will give me my value at the end. So we need the fact that C of 12 is 55. So it's like we're position at 12, our position at 12, plus our displacement of position. And that is 55 plus 40.329 degrees. Now you can see between 12 and 20. See that your derivative is increasing. So the question is like, determine whether the temperature of the coffee is changing at a decreasing rate or an increasing rate. Well, like here is the rate of change. You can see the rate of change is increasing. You could say C prime from 12 to 20 is increasing. I don't know if they'll actually accept that. I looked over the scoring guidelines and they were talking about how you needed to reference looking at the second derivative that they gave you. And you can see that your second derivative is positive. So again, it's if our second derivative is positive, our rate of change is increasing. We're looking at a decreasing rate or an increasing rate. Increasing rate. Here's my rate of change increasing. So that's what they're looking for. All right, so that's a good review of Riemann sums. Now we're going to go into some integral properties and getting some numerical answers. Some things we didn't really get to is the fact that we can split up integrals whenever there's added. So like whenever you have something like this or anything being added, you can split it up. Remember the different ways to accumulate. If you're given that this is the graph of x cubed minus 8, well, to accumulate x cubed minus 8, you could use a Riemann sum to approximate it, or you could use big F of 2 minus big F of 0 which is something you can do here. And you can find big F of 2, 2, 4, 8, 16. So it's 4 minus 16, which is negative 12. And then big F of 0 is 0. So this answer is negative 12. This area is negative 12. And we did that by using an antiderivative. Cool. 2, 4, 8, 16 divided by 4 is 4 minus 16 is negative 12. Cool. But if you were asked to accumulate f prime, well, same deal. F of 2 minus f of 0 will already have f. And I can actually see f of 2 is 0. And f of 0 is negative 8. So if I do 0 minus negative 8, I can see my displacement of f is positive 8. I increased 8. Cool. So that's one thing. Now, the next important thing to remember is if you can use geometry to accumulate, if you're just adding numbers, you're not going to be adding that number to the accumulation. Instead, by separating it, you can see adding 2. If you shift everything up 2, you're adding a rectangle worth of area. You could find this either by using super F and its change from 2 to 12, or and you get 24 minus 4, which is 20. Or you could just say it's a rectangle, height 2, width 10. That's 20. Meanwhile, 2 to 12 of f, I got this 2 by 4. I get this 2, 4. So this is a quarter of a pi 4 squared. So that's 4 pi. I get this 4 by negative 4. So that's negative 8.
It's still pi.
Yeah, get in there. I'll get negative 4 plus 4 pi here. And I'll get 20 here. If you're ever unsure, split it up. You can only split up sums, you can't split up products. You have a constant, you could just pull the constant out. You want to accumulate f prime, it's a video, it's a calculus video. Yeah, f of 12 minus f of 2. F of 12 is negative 4, f of 2 is 0. So this is minus 4. And then this is also 20. Negative 4. So negative 12 plus 20 is 8. Careful. Careful, careful. It's going to be the opposite of the integral from 2 to 8. So I will get the integral from 2 to 8 of f. And then I will subtract the integral from 2 to 8 of 2. 2 to 8 of f is 4 plus 4 pi. Take the opposite of 4 plus 4 pi. Subtract this is 6 by 2, 12. 8. So I'll have the opposite of 4 pi minus 8. I will get negative 4 pi plus 8. It's very important to deal with this later Not right away. It's a great question here because we could separate it. We found this using big F of 2 minus big F of 0. We find this using regular F of 2 minus regular F of 0. We find this by doing 2 by 2 rectangle. We get this was negative 12. We got this was 8. F of 2 is 0. F of 0 is negative 8. So this was 8, positive 8. This is 4. This is 0. Fantastic. All right, find the average F. I'm going to add up all my F's, divide it over my interval. Well, since I found this accumulation in all these, I have negative 20 plus 4, which is negative 16, plus 4 pi over 12. Then, if I want the average F prime, I'm going to add up all my F primes, divide over my interval, and I know that's going to be F of 12 minus F of 0 over 12. So F of 12 is negative 4, F of 0 is negative 8, so that's a plus 4 over 12. Okay, this is the graph of F prime. It's important. I'm told F of 0 is 3. We might have to use that in a second. So I'm just kind of going a level deeper here. Like, yes, I could have F of 2 minus F of 0, but I have the graph of F prime. So I don't want that. Instead, I want to accumulate F prime from 0 to 2. This is 1 by 4, so this is 2. This is 1 by 4, this is negative 2. So this is 0. But this guy, to accumulate F double prime, I want to use F prime of 2 and F prime of 0. F prime of 2 is negative 4, F prime of 0, 4. So this is a minus 8 situation, displacement. Zero to negative 3, you're going backwards. It's F prime. This is F prime. So I want to accumulate this. Oh, look, it's a trapezoid. Base 2, heights of 4 and 6, so this is 10. There's another trapezoid.
Hannah, I told you. What are you told? There was stuff in the mat. There's stuff in the mat.
Yeah. Weren't you at chapel? No. Okay. I got 0 to negative 3, which will be 10 plus 5.5, which is 11.5, but make it the opposite. Oh, heads up. F double prime. F prime of 0 minus F prime of negative 3. F prime of 0 is 4. F prime of negative 3 is 3. So 1.
You're about to get eaten up.
Okay, this is in the right direction. I'm going to split it up. Trapezoid. Base 1, heights of negative 4 and negative 3. So 1/2 base of 1, heights of negative 4 and negative 3. And that's negative 7/2, so that's negative 3.5, which you can kind of just see there. So from negative, oh shoot, negative 3 to 0. So 5.5, 15.5. positive 15 and a half plus a 9. Oh, there we go. So I have 3 times negative 3.5, right? Because I'm going 0 to 3. So I got this positive 2, this negative 2, and this negative 3.5. And then if f is 2x and I want to accumulate f, I can use super f, which means I'll have 9 minus 0 or 9. Cool. This would be the same thing. And then I'd pull out the 3. I'd have f prime of 3 minus f prime of 0. And then I would subtract the accumulation of 2x from 0 to 3, which I did, which is 9. So f prime of 3 is negative 3. F prime of 0 is 4, so I'm subtracting 7. And then this was 9. So I get negative 30. F of 6 equals f of 0 plus the accumulation of the derivative. One, two, three, 4. So this is a 2 by a negative 4. So this is a negative 8. Cool. So if I go from 0 to 6, I get negative 8, and f of 0 is 3. Don't you forget that when you have a derivative that is negative, that means your function's decreasing. If you accumulate a derivative, all you get is how much we decrease. That is not a position, it's a change in position. You need to use f of 0 as 3. You need to use that this is minus 5. This is minus 8, so that you get that f of 6 is minus 5. Now, what if I have f of 0 as 3 and I want to find f of negative 4? 2 ways. You kind of should be able to figure this out now. Let's see if you can kind of understand this. You could say f of negative 4 equals f of 0 minus the integral from negative 4 to 0. Or understanding that if you go backwards, it's the opposite of going forwards, you could say f of 0 plus the integral from 0 to negative 4, which does go backwards. And you're going to get the same answer. Now, what's the integral from 0 to negative 4? This was 10. This was 6. So this will be 3 plus negative 16, or this will be 3 minus 16. All right, and then what I wanted to try to get to, though I don't think it's important, I don't want to waste time, is how you can use the fundamental theorem of calculus to get that this is 8/3. Cool. But what your calculator does is an advanced type of Riemann sum. When they add up y's times x distances. What's up? How we doing? Happy spring break, guys. Peace out. Bunny ears for all. The y's come from x values being squared. The x's takes my interval of 2 and splits it over n objects. So however how many objects that I have. I gotta have n objects. Well, what are my x's that I square? Well, I start them at 0, and I add some multiple of my width. If you don't understand this, don't worry about it. Honestly, like I'm done trying to explain this to students. It'll be one question, and if we have time, great. But I'd rather you get the big gist of this. This will be one multiple choice question on the test. How did I get this? This is A plus K times the delta X. This is the delta X. Why did I say it's a delta X? This is like an X distance. And if we plug this into Desmos and you select certain values for N, you would get closer and closer to 8/3 the more and more objects you use. And that's what your computer does. It does an advanced Riemann sum to get a very good approximation that will be so accurate it'll look like the exact value. But if we kept looking off forever and ever in the decimal land, maybe it would be off by a little bit. Okay, that's it. Good stuff. Happy spring break, everybody. Mr. Mester, out.